What's up, Inspired Vision Calculus class? Today is week 22 Wednesday. Now, if you already titled your notebook week 22 Wednesday, that's totally fine because I'm going to want you to staple in today's review sheet into your notebook. And I'm also going to let you use this tomorrow on your quiz, but I'm not going to let you use notes whatsoever on Friday's test. Alright, as always, it is time to learn some math. And our way that we're learning today is a review game that we will be playing. I'm going to give you a clue about a person on every other slide. By the end of the review, you tell me who that is. Alright, and this joke is just for someone special in the class. Shouldn't use calculus as pickup lines. I wonder who I'm talking about. Alright, here's our first question. Alright, we have the derivative of tangent of x because I'm going to throw in some trig, just like last week, into this week's test. So I'm going to throw in some derivative of trig and some integrals of trig. Now, using the derivative of this, we already know that this is secant squared of x. But I was trying to see if you could prove it using the quotient rule. If you're using the quotient rule, you got to think that tangent of x is really sine x over cosine x. Alright? If that doesn't make sense, I can explain that. But if that doesn't make sense, then we're going to apply the quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so the bottom goes right here. Derivative of the top, well, the derivative of sine is cosine. So that means you multiply two cosines together, you have cosine squared x. Then you have the top, which is sine, but the derivative of cosine is negative sine. So this makes this negative into a plus because now we have sine squared x. And then the bottom, cosine squared is cosine squared x. Now here's what I was hoping you would do with this. I was hoping you would say, okay, we can divide both of this, cosine squared by cosine squared, and that's just 1. And then sine squared divided by cosine squared, that can turn into tan squared x. And using one of our trig identities, this is secant squared x. Okay? Hopefully that wasn't too painful. Here is our first clue. The person that I'm talking about today, their middle name is Williams. That could be anybody. Alright, here is your second question for today. Your second question, we have sine to the fourth power and cosine to the third power. What I'm hoping you would do first is break up that cosine to the third power to be cosine squared x times cosine x. So we still have sine to the fourth power. Then what I'm hoping you would do is break this cosine using an identity of 1 minus sine squared x. Alright, now it's time for U-Substitution. Our U is going to be sine. Our du is going to be something that's already in the problem, and the derivative of sine. The derivative of sine is cosine, which is already in the problem, which is what we want, which would make this a u and this a u. So now we have the integral. We don't have to multiply anything special because the du is already in the problem of u to the fourth power 1 minus u squared. Alright, now we need to distribute. Still haven't taken the integral yet. And now we need to apply the power rule. So if we add 1 to the 4 and then divide by it, because we're trying to get it to be equal to 1, we have 1/5 u to the 5th power. Same thing here. If we add 1 here and then divide by it, because we're trying to get it equal to -1, then we have -1/7 u to the 7th power. Okay, and then since this is indefinite, then it's plus c. Finally, we plug back in our u. And we can write the power with the sign like this. And that's it. Alright, hopefully this all made sense and you're ready for the next question. Okay, now this one you haven't seen yet before. The reason why we can't just say sine squared of x is cosine squared, or 1 minus cosine squared of x, is because we don't have the du in the problem whatsoever. Now I realize I haven't given you this before, but I think you're capable of doing this. You're using a half angle identity. And the half angle identity we want is this. So basically, we're going to turn sine squared x into 1/2 1 minus cosine of 2x. Alright, the next thing we're going to do is use u as 2x, and then du would be 2. Oh, wait, before I do that, I want to break this up into parts. I want to break this up into 1/2 1 minus the integral of 1/2 cosine of 2x. Okay? Now, then if I take the integral of 1, I just have 1/2 of x. That's easy. And then here, the u is this. My du I don't have, so 2 times what equals 1, that would be another 1/2, so that's minus 1/4. Okay, and then we have the integral of cosine u. Hopefully you're able to follow this. So what I did was, since I have 2 parts to my integral, I separated this part right here and the one integral in this part right here. And then I use U-Substitution for the 2x. Since I don't have the 2, I have to pull another 1/2 on the outside. Alright, next. I am ready to take the integral of this. The integral of cosine is sine. So it's going to be negative sine. So it's going to be plus 1/4 sine of u. And we already took the integral of this one. That's 1/2 x. We substitute my u in. And we have this. Okay, be very careful. Make sure you keep using parentheses for the 2x. Okay, now we're ready to plug in our pi into both. So we're going to have 1/2 pi plus 1/4 sine of 2 pi. And then we're going to subtract the answer of 1/2 times 0, which is just 0, plus 1/4 sine of 0. Okay, your final answer you should have is pi over 2, because this answer comes down and these should just cancel out, because sine of 2 pi and sine of 0 will cancel each other out. Alright, hopefully that wasn't too painful. I might make something like this bonus since you've never seen anything like this before. Your next clue is the person that I'm talking about loves Kenny Chesney. Alright, here's number 4. Number 4, we want to try to make our integral look like this. Because this is one of the rules that we've worked with before. The derivative of tan negative 1x is 1 over 1x squared. Well, the thing that's giving us the biggest problem right now is this 4. So if I take everything and multiply by 1/4, I can get that 4 to turn into a 1, which is what we want. So that means we're going to have to multiply everything times 1/4, and this is what we're going to be left with. Okay? Now we have something we can work with, tan negative 1. And if we have tan negative 1, then we're going to want to use U-Substitution. Now here's where this is tricky. We need our U-Substitution. We need to think, what can we, because this is squared, we need to think our U is going to be 3 over 2. The reason why it's 3 over 2 is because 3 over 2 times 3 over 2, which is squaring it, would be 9 over 4. So that takes care of the squaring part of it. So our du, 3 over 2x. That way I can just write u squared when I'm finished for my next step. So that means my du is going to be 3 over 2. And if my du is going to be 3 over 2, I'm thinking 3 over 2 times what equals 1, because I don't have anything yet, and that's 2/3. So we have to pull a 2/3 out on the outside. We already have a 1/4 on the outside, and now we can write this. Alright, so our next step, 2/3 times 1/4 is 1/6. And then we have 1 over 1 plus u squared, which turns it into tan negative 1. So, or the inverse tan. So we have tan negative 1, and then our u plus c, since it's indefinite. Well, I got one more step. That is to plug in our u. So it's 1/6 tan negative 1. Our u is 3 over 2x. And that is the final answer I'm looking for on this question. Alright, number 5. Number 5 should give you a little bit more joy, because these are pretty easy. On number 5, we can use the easiest rule we know. The easiest rule we know is to do this. since this is starting at 1 and going to 3, 3 is my n. This is my first term, which means I got to plug in 1 into this equation. 1 plus 4 is 5. Then we got to plug 3 into that equation, which is 7. Alright, we're excited because this is really easy. And our answer is 18. Okay? Going to give you a fair share of these tomorrow. Now, our next clue is the person I'm talking about loves chicken parm. Okay, here's the next problem. Okay, in this problem, there is multiple ways we could approach this. Just because I have to justify this myself, teaching you this, we could break this up to be this. Which means right here we have to do n plus 1 divided by 2, and right here we have to do n plus 1, 2n plus 1 divided by 6. However, I know none of y'all are going to do this. So here's another way we could do this question. We could, since this is pretty easy, 1 to 3, we could plug in 1 here into both of those, and our first term would be 2. Then we could plug in 2 to both of these, and our next term, that would be 3 times 2 is 6, minus 4, that would also be 2. And then if we plug in 3 into both of these, that would be 9 minus 9, which would be 0. Since I'm doing a summation, that means I have to add all of these together. And if I add all of those together, I get 4. That wasn't too bad. That's pretty easy. And it's because of going 1 to 3, that's not really that hard. Now, if you're using your calculator, you could type this in. Since I know I showed you your calculator, just make sure if you're using your calculator, you change your k into x, and you write it like this. Alright, since I know all of y'all have the answer by now, I'm not going to spend much more time on this question. So, oh, there we go. So, no clue on this page. Alright, here's your next question. Alright, when I was thinking about this question, I was thinking it would be a whole lot easier than it actually is. And then I started working it out. So here's the deal with this question. If you can figure this out, I'm going to give you a lot of bonus. I promise. Your lowest grade, I'm going to give you bonus. But you have to be able to explain the steps, because it is a problem that I haven't taught you yet. The way to do this problem, it's called integration by parts. I haven't really taught you that yet. That's one of the main things that we're going to go into next. The reason why I picked this problem is because I really was wanting you to think of a problem that looked like this. And in order to do a problem like this, I'll get you started. I wanted you to say that the u was the ln of x and the du is 1 over x, which we don't have. So you would have to multiply the whole thing by an x, and then you have this. Okay? So here's the thing. I'm going to give you the top question is extra bonus. If you can finish this, I'm going to still give you bonus, just not as much. That way you have extra incentive. If you can figure out both, it's going to be worth more. If you can only figure out this bottom one and finish that off, then I'm just going to give you a little bit of bonus. Alright. Now, our next clue about a person is that they really care about football. And here is our next question. Alright. I know we haven't really talked about right-hand endpoints, but I figured you can handle this question. First of all, if I plug in 0 to here, that means my first coordinate would be 0, 2, because that's my answer to this, just using this equation right here. 0, 2 on a graph would be right here. That's my first point. Then if I use 1, I plug in 1, that's 2 minus 1 squared. So that would be 1, 1 as my next point. And then 2, if I plug in 2, I would have 2, 0. However, this should be making a curve because we have x squared. Something like this. Alright, now, my picture's not very good. Maybe yours is a little better. Here's the whole point of this question. We want to figure out what this area, because we're only talking about from 0 to 2 is. So the area right there. And we're definitely still make sure we're dealing with a curve. Alright, now, there is several ways we're going to approach this, and we'll do the easiest way last. So first off, they're saying use right-hand endpoints. So if I go from here to here, that's using my endpoint from 1 to 0, and I make a rectangle. And we can find the area of this rectangle. The area of this rectangle would be 2. Everybody agree? Then I can find the area of this rectangle using right-hand endpoints. The area of that rectangle would be 1. Now, that's all they're asking for here, is to add up these two areas to get 3. But then they want us to evaluate. The way we can evaluate is to actually use, we can either use Riemann Sums, or we can use our integrals. So if we're doing a Riemann Sum, our question would look like this. And if we plug in each number, 0 here, our first term would be 2, our next term would be 1, and our next term would be -2. Well, this gives us a little bit different answer. This means my area would be 1 using summations. Let's do it one more way, and this is kind of what I'm looking for and what I think you can handle. Let's actually take the integral of this. If we take the integral, then we're going to, here, let me write it. We're going to have an x here, and then we're going to have minus 1/3 x to the third power. And then we're going to plug in 2 into this. Get this answer and subtract, plugging in 0, which is just 0. And this is the final way I want you to represent this answer. So that would be 4 minus 8/3. Using your LCD, this would be 12/3 minus 8/3, which would be 4/3. Now, to me, 4/3 makes the most amount of sense as an answer. And maybe because my picture's not drawn very good, but it makes a whole lot more sense than this. But it's just different ways to express this answer. Alright, here is number 9. This should hopefully be very easy. I was trying to think of a question where you had to remember to move up your denominator. So if we moved up the denominator, then we would really just have the integral of x to the -3rd power. And if we have x to the -3rd power, and then we do the power rule, then we have an exponent of -2, and then we should do -2 times what equals 1, and that would be -1/2. And since it's indefinite, it's plus c. Now the final way I want you to write this answer, I want you to think, okay, well, x to the negative 2 power, we should move that back down to the denominator. So this is a little bit better way to write this answer. All right, hopefully that was easy for everybody. Here is our next clue. The person that I'm talking about is really, really big. So this is a really big clue. You got to think of someone that's really big and likes everything else that I talked about. 2 more questions left. Here's the next question. All right, when I was looking over stuff to give y'all for a quiz this week, I came across this term, and I thought it was really funny because you're probably going to flip out about it. This just means x. It's just another way to write a variable. So it's a little bit easier because we're not used to working with that as a variable, just to think of 5 square root of x. Now, what I need you to do next is to write your radical as an exponent. Which means you have 5x to the 1/2 power. Alright, now we're ready to do the power rule. Which means we add 1. So that's 3/2. Then we got to think 3/2 times what equals 5, which means we're taking 5 and we're multiplying 5 times 2/3, and that would be 10/3. Alright, now I'm totally fine if you keep this as your final answer, but I really want you to convert this back into a radical. First off, 10/3 can look like this. And then x to the 3/2 power means you have 2 going to 3 once, 1x out, and 1x left behind. There comes the 1/2. And then plus c. Okay, here comes our last question of the day. Our last question, what I was hoping you would think about when you see this is to break this up to be cosine x over sine of x times 1 over sine of x. Cosine over sine of x is really cotangent. 1 over sine of x is cosecant. Now, the easiest way to think about this now is the derivative of cosecant is cotangent x, cosecant x. Just kidding. It's really negative cotangent x, cosecant x. So that means my answer has to be negative cosecant x plus c, which is this answer. Alright, our last clue is the person that I'm talking about has won 2 Super Bowls with 2 different teams. That's only one person in the world, and only one person has done that. Hopefully you have figured out who I'm talking about. Okay, until tomorrow.